Good afternoon, everybody. I hope you can all hear me clearly and see me, I guess. So I'm going to move this camera out of the way, I guess. If you can see it on my screen. Linda, do you see that on my screen, that camera, or no?
I still see you, Gisbert, yes.
Okay, but you don't see the window where I'm showing up.
Yes, everyone can see you.
Okay, very good. Okay, welcome to the NTMA, National Tooling Machining Association presentation we're going to do today. This is part of our tech team presentation series, and today we're going to talk a little bit about how to improve process reliability, and we're going to go through the different processes from setting up a machine, what is critical for a machine tool, what components you really utilize to ensure that your parts are perfect the first time. And as we all know, the parts are getting more complex. Everybody has more pressure to produce accurate parts in a very short period of time, so you can't really afford any rework anymore. I'm going to go through that a little bit today, and I would say if you have any questions, put it in the chat box on the bottom right there of your screen. There's a little area where you can put that in, and Linda will help me to answer the question at the end. So write them down, write them in there. We're going through them at the end so we can move on and stay as much on time as we can. So my name is Gisbert Ledvon. I'm here at HEIDENHAIN. We are a control manufacturer and motion control manufacturing company. So everything what moves when it comes about precision, that's what we're going to do, and that's what we produce. And I'm here working on the machine tool side. So what a lot of these job shops, and you as a job shop probably utilizes on a daily basis, and I try to get you some newer information on this new technology. So we're going to talk a little bit about HEIDENHAIN in the beginning. Then I give you a little bit about what are the fundamentals when we talk about an accurate motion control. So if you select a machine tool, that's something you might want to consider or take advantage of on your own machine you have maybe on the shop floor. There's new technology out there on cameras. There's also new technology on touch probes. So I'm going to touch base on that a little bit. Then I talk a little bit about some CNC features and functions. Some stuff what goes even beyond milling, where you have multitasking capabilities within the 5-axis machine, for example. We're also going to talk about quality of the finished part, uptime, making sure that the machine is up and running, so predictive maintenance, we're going to touch base on that a little bit. And at the end, we're going to look at how can you plan a process, how can you plan a job, how can you do that hopefully paperless, and how can you organize and monitor that job and make sure that that process is really organized well. And that is going to conclude the presentation, and we have a little question and answer session. So a little bit about HEIDENHAIN before we get into the technical part of things. So this is HEIDENHAIN in Germany. As you can see, it's on the lower right here, southeast part between basically Munich and Salzburg. Salzburg is in Austria, as most of you know. And HEIDENHAIN is about 4,000 employees in this town in Traunreut. So we're expanding outside the city because, as you can see, we're moving up in the air, but we're running out of space now. So all the R&D and the main support and production is based out of Germany. For the United States or North America, we have facilities up in Toronto, in Canada. We have 2 locations on the West Coast, one in San Jose near San Francisco, one in Los Angeles or in Orange County, and then in Mexico, as you can see down here north of Leon. And the headquarters are here in the Midwest, in Chicago. That's where I am located and our team is located. And this is how the facility looks like. We have production in the back here, the training center in the front, and in the service department for phone support is right here. And then we have a large warehouse to provide our customers locally with parts you might need to make your machine running and keep it running. So we're about a half an hour away from Mohair. So as I said before, HEIDENHAIN is in the business of motion control. And these are all kinds of brands HEIDENHAIN owns, but I want to focus today on two things. What is machine tool, and one brand I always like to be mentioning, what is the Akrite brand. That's probably the only control system what is really made in the United States anymore, and it's made right here in Schaumburg. So it's American produced product for knee mills and DRO systems for manual machines and so forth. So, and then everything else is other motions, all the way down to semiconductor business, where we really have to split microns in accuracy. So a little quick overview about the product line. We have encoder technology. You heard probably of glass scales, linear encoders, what we call them. Then there's rotary encoders, and these becoming more and more important as well when we're working with 5-axis machine tools, because they have to be as accurate in their positioning as a linear encoder, like a direct measuring system you have on the glass scale encoder. Then we build control systems and DROs. I talked about that. And we're also providing technology for measuring tools or touch probes for inspecting and measuring and setting up workpieces, as well as equipment to check your machine tool. Instead of using a ball bar, we're using a little bit more sophisticated technology to use this grid plate technology. I'm not going to go into that today, but if you have more questions, you can always come back to me and learn more about that. So if you look at a general machine tool, the items I highlighted in yellow here are really the components of the machine tool, what are important and responsible for the motion control of the machine. In other words, you want to make sure that that machine tool moves right at the right time, at the right speed, to the right location on your workpiece, machining a part. So as you can see here, we have linear encoders or glass scales on the x-axis, z-axis. Then you have motors and drives, maybe with encoders in the back. Then you have a tool changer, what is also driven by a motor and an encoder, because you need to know where that position is. So all these things are important in a machine tool, and all that is controlled by your CNC. And maybe you have a remote control as well, or what we call a pendant or a hand wheel, what allows you to move these axes manually. So one thing I want to point out too, when we talk about accuracy, one thing is very important, specifically if you do production parts, or even if you do just one part where you have a high mix and low volume, you want to make sure that you always position the table, the tool, the whole machine movements in the right location at any given time. And what you see here is a phenomenon what is known, I think, but forgotten over the years because people don't talk too much about it anymore. And you see on the bottom there the ball screw with a heat camera. We capture that information. And what that shows you, these highlighted areas heating up when you machining and moving the table back and forth, that ball screw heats up. And what does that mean? It expands. So that means if you measure the rotation of your ball screw, you're not positioning absolutely accurately. And that's why you should really look into linear glass scales on your machine tool in order to avoid and overcome these type of problems. Now, if you dig a little bit deeper into this type of motion control system, on the left-hand side, you see what we call a semi-closed loop application. What does that mean? You basically have an encoder what counts the rotation on your motor here, what is related to the pitch of your ball screw. So you know if I do X amount of rotations, my table will move X amount of distance. And that's basically the end of it. Now, we talk about a closed loop system, we closing the loop between this rotary encoder and what actually happens to your machine movement. Like we saw before, if the ball screw warms up, the count of your encoder is becoming very inaccurate. And that's why when you have the glass scale really checking where that table or that axis is at any given time provides you the most accurate measurement run of your machine tool. So there's a lot of talk about, you can mapping your machine and you can measure it, you can software compensate for that. You can do a lot of that, but you cannot really overcome these different temperature deviations you might encounter during a machining process, because you never know where that machine is warming up and when close to the. And here is an animation what shows that a little bit. The top window gives you a temperature deviation in Kelvin here. And cutting this part on the left-hand side. And the middle window with a blue background shows you the movement of the cutting tool. As you see, we're moving on the outside, we're cutting pockets. So we're moving along the entire axis, back and forth, right? So here we have another start on that. And if you can see in the top window, the temperature is going up and up and up because the ball screw is and on the bottom, in the last one down here, you can see within 5 minutes we have a 10 micron deviation just on cutting this little part of it. You will really see that that there is a deviation within 5 minutes. Now, let's talk about setup. So what's critical for setup? And we're going to talk about machine setup, we're going to talk about part setup, and then we talk about program setup. And some of you already heard about digital twin technology, so we talk a little bit about that as well. So what is new on setting up parts? You certainly can use an indicator today, but there's also technology now what is tied into a camera. And here's a system we're using on the HEIDENHAIN side, where you basically take a picture of your perfect setup. That picture is stored in the control system on the CNC. And when you bring in the second part or the second pallet, that picture is compared to the perfect setup, right? And that's what we're demonstrating down here in this window here. So here we have a part, a chuck, what is sitting on the table. And as you can see here, somebody left the wrench in there. So the control will now look at this and say, hey, there's something wrong with that picture of a perfect setup. What do you want me to do? So it's a warning for the operator to take this out. So you have a secure setup utilizing a camera system. And that's something you can put on the machine later on. You don't have to do that immediately. You can put this also in the pallet changer, wherever you want to place this, and then connect it to the control. The other way to do it, and a lot of you do this already, some of you don't, is utilizing touch probes. And there's many touch probes out there. And as I always say, the HEIDENHAIN touch probe is probably one of the most kept secrets in the industry. But we make touch probes for all kinds of applications, grinding and milling and turning operations. So there's many touch probes out there. The market is big. There's a lot of different companies who are offering these. And the different sizes, different pressure point on each touch probe, depending on what material you maybe want to measure. And then in addition to the tool, the workpiece touch probe, what we're seeing on the left-hand side here, you usually have a receiver. So if you don't have a cable connected, you also have a signal receiver, either infrared or radio frequency. And then you have these tool setters. A lot of people using laser tool setters, but there's also less expensive solutions, so mechanical devices to measure and check a tool for breakage and so forth. So let's take a look at some of the newer touch probe technology. What makes it important to look at when you look at some investment to buy touch probes? I would recommend look at the latest and greatest. Don't just buy because there's a brand name out there. You just want to buy it because you had it before. Things move on, and even in touch probe technology, where there's more sophisticated things you can take advantage of to make more accurate setup. So for example, specifically if you have a 5-axis machine tool and you have new operators, you might want to look into a collision protection on your touch probe. So when you hit something by accident, you don't just break that $5,000–6,000 touch probe. If you want to look at absolute perfect accuracy, you want to make sure that there's a decoupling function on your touch probe, what you see down here, so you don't transfer the heat from the spindle into your touch probe, what would grow, and you make inaccurate measurements. Also, optical sensor technology is really helpful because they last much longer than mechanical ones. Also, if you have a tool touch probe, it's always good to have a direct measurement down and no mechanical devices on the side that also doesn't give you a lot of accuracy. Look at if you can do cleaning your workpieces before you measure something. So in this case, you can have a workpiece cleaner. So if you have coolant through your spindle, you can blow the coolant or the air through the touch probe and clean the area you want to measure. So that's important. And then there's other functions to save battery life. You want to make sure that the touch probe shuts down when you don't use it, so the batteries don't get drained. And you're making sure that you can check the battery before you leave on Friday night, so that the machine doesn't stop or break your touch probe if the batteries are dead. So those are all things to consider when you're looking at touch probe technology, and make sure that you take care of that. Within the touch probes, certainly they usually sit in the tool magazine. You want to make sure they're clean, that they're aligned correctly, that they haven't got any damage during any measuring processes. So make sure that you utilize that. A lot of the machines certainly come standard now with touch probe cycles. So look at that, make sure you understand all of these cycles so you can properly use them, and the information the machine will measure for you is usable, and you understand what it does when it aligns apart, or if you have a 5-axis, maybe you line or tilt your table or your work plane. You want to get really good with understanding the touch probes and the touch probe cycles properly, so you can really take full advantage and minimize your setup time. The other way to do touch probes, like I said, is to use them for tool measuring, and not only measuring the length and the diameter or the radius of your cutting tool, but you can also check the wear or breakage. So let's say in between machining a couple of different parts, you might want to run over and program a little check to make sure that the tool is not broken. And if it's broken, maybe you program that you want to bring in a sister tool, so you don't have any issues running in the air, not cutting anything, and the parts are not finished, right? So those are things you want to use this for, as well as the wear. So it really comes down to high accuracies. You might also want to do a wear check in between your operations. Another recommendation I have is, specifically you have a 5-axis machine and you're in an environment what is always changing temperature-wise, and you're not quite sure if the machine is stable. I would always recommend to run what we call in our control system Kinematic Opt, where you're basically measuring the pivot points of all the axes, utilizing the steel ball here, and recalibrating the machine. Specifically, if you cutting complex parts, I would also recommend that you mount that ball as close as possible to the workpiece you're going to machine, to really tighten the tolerances around that area of the machine tool. So take advantage of all these functions and recalibrations before you even get into the cutting process. So just to summarize a little bit, before you prepare for probing, in other words, measuring and setting up a part, warm up the machine to the cutting conditions. So whatever you're going to use, how warm the machine is, what RPMs you're going to use those to warm up the spindle, warm up the machine, so you have the machine as stable as possible. And then measure. If possible, use a probe with a thermal and collision protection. Calibrate the probe in the machine, because you want to make sure when it sits in there, it sits correctly in there, and you don't check it outside, because maybe you have a little spindle run out, and if you indicate your stylus in the machine, you're always a little bit better off to do that and get the maximum accuracy. Make sure the stylus is correctly installed, there's no chips on there or broken or loose. Make sure your batteries are in good conditions, because on some touch probes, if the battery is dead, the machine will not recognize that there is a trigger point, and it just keeps going and it will break your stylus off. So make sure the batteries are in good shape. When you have large distances, let's say you have a really big machine, a couple meters long, you definitely need a radio frequency touch probe. Some touch probes like ours, you can switch between radio and infrared, so you can measure short distances, or if you have a longer machine, your signal will get transmitted via radio frequency. So you got to take that into consideration when you're looking into a touch probe. And like I said, you can also use infrared if you really have a short distance and you don't want to use any cables or can't use cables. Make sure the part is clean before you measure, of course. So those are the key items when we're setting up. The second thing is, now let's look at your control systems. Your control system is becoming more and more sophisticated. CNC data and data management is very important these days, because you want to digitalize your shop floor. You want to bring data into the control as much as possible without utilizing any paper. Everything should be electronically, so it can be updated automatically on your server. So we're going to take a look at how your control system should work and what you should take advantage of cutting accurate parts. So some of the control systems now offering import functionality. And you will say, well, I usually program all my parts on the CAM system. Agreed. And absolutely, you're right. And most likely you will do that probably 80–90% of your jobs. But let's say you have a bottleneck. Something is, you need a quick fix there. You need something small. You want to support a part, or you need to create a quick fix there to hold something specifically. And you don't want to tie up your programmers with a simple part you want to cut. So look at your control. There should be, on some of the controls, you will be able to import DXF or IGES files. And you can just select the area you want to machine, and it creates a program for you. At least that's on HEIDENHAIN, and I think there's others out there who can do that too. And then you, in the Flash, you can program right on the machine. And you can, with the graphics technology we have today, or touchscreen technology, you can even zoom in and really can look at all the details, so you can really verify everything before you machine the actual part right on your control system. And you'll be much, much faster. You don't hold up a programmer who is on a big project, designing a big mold and writing programs for 5 axes, and you just want to create a simple part. You might be able to do that much, much quicker on the control. And then there's other functions you might have not looked into. For example, we have customers who didn't know that they can do interpolation turning. In other words, you don't need a mill turn machine for that matter. You just have the axes moving around to turn a part for you in one setup. So you minimizing inaccuracies, you emphasizing on one setup, and you can machine, you turn something on the part, and at the same time you can mill something on the part, you can drill something on the part. So look in your control capabilities. Make sure you trained right, you know all the functionality and how to take advantage of them, maybe even down to gear cutting and gear hobbing. But in those cases, you need to have your table and your spindle absolutely synchronized. So there's some limitations from one machine to the other, but take advantage and look into the control. You can do a lot in there. What is also more and more important is keeping track of your parts, the parts you're producing. And there's new technology out there, what we call the data matrix code. And this is a really nice code, what looks like a QR code if you want. But the beauty about this is you basically can create a simple text, a part number, a description even, and you put this into the control, into the program, and you running drilling cycles, and with these little, the drill goes in there and it creates these patterns. So when you walk up there with your iPhone or any mobile device with a camera on it, you're running these QR code applications, it will tell you this is part 155 made by company XYZ on January 24th, for example. So that information can be stored in this, and you can put this right on your part. Very simple, very easy to do, the data matrix code. Now the digital twin. Everybody talks about it, but I would say be careful what you're looking for when we talk about a digital twin. There's a lot of possibilities to simulate a machine tool, and probably it's okay because you're looking mainly for collision monitoring and maybe crashes. So you want to make sure the program runs right. The digital twin is good for that, but I wouldn't even go there. You can probably use a programming station, like you could use a HEIDENHAIN programming station, simulate the whole thing, or you can use a CAD/CAM system with a verification software, and you can simulate your tool paths and make sure that you don't have any collision. When I'm talking about a digital twin, I'm really talking about the entire mechanics, the entire motion control system, and the entire behavior of my machine tool. So it's basically a very unique configuration I have as a digital twin. And the reason why I'm saying that is, if I want to make cost calculations or I want to estimate a job, when I use that type of digital twin where I'm really duplicating the behavior of the machine and the speeds and feeds, I can really make accurate estimates on how long it's really going to take to machine that part, because now I really know the mechanical behavior of my machine tool utilizing this digital twin technology. So you can really take full advantage of your workpiece area, obviously, your rotary table, your tilting table, tilting head, whatever your configuration might be. And you can really take full advantage of what's the speeds and feeds on this particular machine. And then you can use that digital twin to do your cost estimation and forecasting and quoting process. Another thing I want to talk about is quality. And to improve quality, and here's an example, as you can see on the right-hand side here, we're engaging the entire length of this cutting tool in the cutting process. And you can do that today because there's solid carbide tools out there, but also the dynamic of the machine tool allows you to do this now, and there's programs from CAD systems out there now. We even do it now on the control directly with what we call OCM, optimized contour milling. But that's going to help you with the quality of producing your part. So let's look into what are features out there you should take advantage of when you want to make sure you are producing a quality part. One thing what is out there is what we call the adaptive feed control. And the adaptive feed control works basically on looking at spindle load you have defined for a specific cutting tool in comparison to what the spindle load should be for that particular cutting tool. If you want to improve productivity and you have parts what have different thicknesses, or you have a casting part where you have inconsistent materials you're removing, AFC is going to help you to machine as quickly as possible, increase your speeds and feeds. If there's not enough spindle load there, you can go faster. Or you can use this technology also to ensure your quality and making sure that when your cutting tool is broken, like in this case up here, that the process stops, because you're going to damage the part, the machine, the spindle, your work holding device maybe. So it's a very costly expense. So you can basically take advantage of this technology to check your spindle load. So if the spindle load goes beyond the capacity of the spindle, you can program the machine to stop the process, change the tool, or bring a sister tool in if you feel confident to do that, or just stop until somebody can come in and look at that. So it really improves your process reliability. Your load on the spindle is monitored, so you don't damage anything there. So a really nice feature to look at. And specifically, if you want to use the Tricorial milling technology, right, where you moving an optimum part, a tool path, and engaging a cutting tool at very high speeds, at full depth, to get straight walls, to have equal wear on your cutting tool, and you can optimize the movement. So you can really cut very efficient, high accurate parts to super surface finish quality. So we did an example here. If you use this Tricorial milling technology, on the left-hand side, you can see we did it with a conventional solid carbide tool, 10 millimeters or half an inch roughly in diameter, machining some high-speed steel, or tool steel, I should say, at these normal cutting parameters, step overs and so forth. And it took us 20 minutes to cut this part, as you can see on the bottom, conventionally machine that out. On the right-hand side, we did the same part, and we used the optimized contour milling. So now we're optimizing the movement of your part, of your tool path, and increasing our feed rate. As you can see here, we have 250 meters per minute versus 157. And we can go all the way 22 millimeters of depth. So 4 times, 2 times in this case, 2.5 times the diameter of the tool. You can go 4 to 5 times now, actually, in some cutting tools. But just even here, very conservative, we're going down to 6 minutes to cut the same part. So a significant improvement of machining time and productivity increase. But what is also important, cutting cost by utilizing the entire length of your carbide cutting tool, allowed us to make 6 of these parts with 1 cutting tool. We machined that in 42 minutes roughly. And the conventional way, we produced 6 parts. Again, it took us 2 hours and 9 minutes, but we had to buy or use 3 of these fairly expensive solid carbide cutting tools. And you can regrind them and all that good stuff, but it's still much more expensive and still not really efficient to go conventional if you can use this Tricorial milling technology. Now let's take it one step deeper into this technology. If you're going beyond high-speed milling and you really want to go into grinding now, so you can set up one part and you can grind that part or certain portions of the part, would have maybe functional surfaces to maintain maybe oil or other lubricants in that area. You might need a surface what is to be ground, and you don't necessarily want to take this out of the machine. So look at your machine tool. Maybe you have a 30,000-40,000 RPM spindle speed available to you. So think about, maybe you want to even consider grinding or jig grinding with your machine tool if your control allows you to do that. Look into that, and you get better surface quality and higher accuracy, because you can really address the grinding tool with a grinding wheel, and you're looking at accuracy less than a micron on that. So there's jig grinding technology out there for 5-axis machines. So again, improve your quality, surface finishes, and so forth. The control will guide you through this. A lot of us who just using cutting tools, maybe not so familiar with what is required there, but the control system usually tells you exactly what numbers to put in where, what's the diameter, what's the length, is there an angle on it. So there's a nice interactive menu what guides you through that process, so you can easily do this grinding or jig grinding on your machine tool. And here's a little example where you can see the redressing process of the grinding tool right in the 5-axis machine. Right. So now let's talk a little bit about how are we gonna make sure that the machine is up and running all the time, running over the weekend, producing my parts, and we're gonna talk about cutting tool monitoring, what is new, component monitoring. You know, sensor technology is out for a few years now, but you want to take advantage of that too and check on your machine or the next machine you're going to buy. And you want to look at predictive maintenance. How can I monitor that, and how can I say in 3 weeks I need to do a maintenance on my machine? So let's talk about something brand new. We just introduced this, so I thought I'd share that with you. This is what we call the camera tool inspection system. And this system actually looks under a microscope quality at the cutting edge of your cutting tool. And what does that mean? Let's say you're running 5 parts, 3 parts, and now you want to do a very last finish cut, and this finish cut has to be perfect. What you could do here, you would just bring the tool in, bring it in front of the camera, and the camera will look at it and determine if the cutting edges are still good enough in order to do another cut, another tool pass, so you get that surface finish and the quality you're looking for before you're running that tool pass. So really unique tool and fully automated. So something, if it really comes down to quality and automation, I think that's something you really should look at and make sure you have that type of quality control in the machine. The other thing is, and this is a little statistic, what we learned from customers who experiencing downtime, and as you can see on the right hand side, there's a bearing what went bad, and mainly it's the spindle, right? That's the biggest problem. 80% of why the machine is not working anymore is usually a spindle failure. So you want to look at what is out there. Is there technologies, there's sensors in my machine to look at the spindle load, vibration, maybe you have an imbalanced tool, all these things, collision protection. Look at all that and take full advantage of it, so you can do some kind of a predictive analysis to make sure you don't overload your spindle or you damage it. And when it comes to a hot job, the spindle doesn't work anymore and you'd be really in trouble. So that's on the predictive maintenance side. So now let's look at data. Everybody talks about data, and more and more people going into this digital shop floor mindset, where we want to do planning, preparing, machining, and then at the end of the day, we want to monitor it. Did we really do a good job? Did we efficiently machine this part? What can we change? And that's part of your manufacturing chain within your shop, maybe. So let's look at what's available there. One thing we have to recognize now, everything is going more and more paperless. So you want to make sure that your CNC system is available to receive information, to get access to a server, to a setup sheet, to an ERP system, that the CNC can be connected to a robot to load and unload parts. So your control becomes a little bit the nerve center if you really want to run full production. And I think you should really look at all these options you might have on that with different protocols. You can connect your machine to your network. One thing I personally like a lot is a system, what we call at HEIDENHAIN is flexible batch processing manager. And there are systems out there with your robots and other control systems, what maybe you have an automation cell in place where you could do something similar. But really look into that and how this works. At least I give you an example, what I know on the HEIDENHAIN side, where you basically be able to set priorities. So I have all these jobs lined up, the different pallets, and as you can see here, these check marks mean I have a preset, I have tools, and I have a program available. And I also know how long my cutting tool is still lasting. As you can see here, this part will take 6 minutes to machine. My cutting tool will last at least another 9 minutes, so I'm good to go. Down here, I got problems. As you can see, the control now looks at all the other upcoming programs and sees, okay, my cutting tool on this job will only last 9 minutes, but the job is going to take 10. I got a problem. So I get a warning and you get alerted and you can make changes before that job comes into your machine. So look at these type of systems, what gives you a lot of flexibility to run 24/7 unattended, and not only unattended, but you're really producing parts because the system will check for you what's available and what works and what is missing to run the part. And then the last one is monitoring our processes, right? So we want to look at the machines. Can we monitor them when we're on the road, when we work from home? Can we inform people when there is a problem with the machine via a messenger system with emails or text messages? Can I look at the different jobs like we just did? Can I collect signals? You know, is there signals on the bearings, heat transfer, the coolant level, and maybe there's information about maintenance I want to look at. I know I have to do maintenance in 2 weeks, so I don't schedule something in 2 weeks or a big job in 2 weeks because I have a big maintenance job to do on that machine. So all these things should be part of process monitoring, predictive maintenance, and planning. So for example, what is important that your machine tool can be connected either with OPC UA, MT Connect, very popular in the United States, what is a free protocol. Although some of the machine tool builders charge you for that to get the information out of the machine. Modbus, that's something when you don't have an Ethernet connection on your control, so you're just checking signals, maybe a green light, red light, so you can utilize that for collecting data. And on the HEIDENHAIN side, we call it HEIDENHAIN DNC, where we just plug a Ethernet cable into the control and we can collect all this type of data. But every machine is a little bit different, every control is a little bit different. So, but usually you can look at the machine efficiency, you can look at is the machine running, that usually is a green, you can do analytics, and there's very sophisticated systems out there where you can do all kinds of things. So I would recommend you really looking at something what is right for your shop, the right size, simple, easy to integrate, plug and play, and you get the analytics automatically generated for you, so you don't have to be a scientist to understand the data. And then make sure you have some mobile device capability, so your iPhone, your iPad, or you'll be able to do it from your office, linking into the machine to look at data and make decisions based on that. You can go deeper into this. And one thing I just did a little calculation here, very simple. Let's just think 10 minutes on undetected machining time. So where you know there's something and the machine didn't run because of this reason, and you know what that reason is, you can identify this reason. It just saves you 10 minutes. And you got 5 machines and you're running them in 3 shifts or less. You can divide this number, whatever you want. And let's say you're just running the machine for 264 days at a rate of $80. You're looking at about $53,000 a year you did not bill because you wasted 10 minutes per shift on your machine. And if you have a monitoring system, that's going to pay by itself within a couple of weeks, a couple of months. So it's really critical to really look at that to ensure that you have proper monitoring capabilities to save money, to be more productive, and identify bottlenecks within your shop to improve your quality as well. So in summary, sorry it's a Heidenhain video, but I just want to summarize what we talked about. So you really want to make sure that you look at all the components what are important for your process. The machine tool itself, we talked about the closed loop system. You want to make sure that your programming system, your CNC, is up to speed, that you have access to a server, you can bring data in. You want to monitor your process. You want to look at that at your fingertips if you're at home, if you're traveling, if you're somewhere in the shop. If you have automation, make sure you have some kind of a flexibility to use like a batch process manager to set priorities. And then, like we started out with, make sure that your technology you have on your machine tool or will buy for your machine tool is the latest and greatest and fastest. And then don't forget touch probe technology. It's a very inexpensive investment, but it will help you a lot to set up parts efficiently, picking them up accurately. And then the other thing we talked about were the Tricorial Milling technology, what takes a lot of advantages of high-speed machining, high spindle speeds, and optimizing your engagement of the cutting tool in the cutting process, minimizing your wear and improving cutting times. So that's all from my part. I know we're a little early. It's about, we have about 10 minutes left. So Linda, I don't know if we got any questions through the chat box or not. I don't see anything in here at the moment. So if we don't have any specific questions, then I appreciate your time. Looking at this, Linda just tells me that she lost the connection, so she can answer. But I'm looking in the chat box and I don't see anything right now. So I appreciate your time today. If you have any more questions, feel free to reach out to us, either to me under gledvon@heidenhain.com or to our application team here. We'd be happy to answer you your technical questions, help you with anything you might want to try or look into a little bit deeper. We might not have always the solutions you're looking for, but we're willing to help you to find those. And in most cases, we certainly have the solutions, but if we don't, I have no problems to steer you in the right direction and talk to the right person to get a solution you're looking for. So thank you very much. Appreciate the time you spend with us. I appreciate that NTMA is putting the invitation out. Again, this was recorded, so if you want to go back to this later on, you certainly can. And I wish you all a nice rest of the day, and hopefully you're enjoying the upcoming summer. Take care. Bye-bye.